In this video, we are going to go over two examples with method of least square. So the goal is to find an equation of a line using the method of least square. And this is a regression analysis, very similar to the regression analysis. What is a regression analysis? This is a process of fitting an elementary function to a set of data points by the method of least square. The mechanics of using this regression technique were introduced in chapter 1 back in Math 121. We began with the linear regression. So linear, as you recall from algebra class, that's a line y equals mx plus b. So we are going to come up with an equation, linear function, which we use that as an approximating function for our set of data points. Now, we do have a very, very long and messy formula. So our base formula is y equals ax plus b. Now to figure out a and b on these coefficient constant function, we use these messy formula. Now, you do not have to know the proof, but if you want to know where they got this formula, please read. So the whole proof is very long, so I'm not going to go over on this video, but you can read the proof of the theorem. Proof of theorem is on textbook. It's 2 full pages. Page 471 and 472, and you'll see where they got this messy formula. But you do not have to know the proof in this class. We'll just use this formula to come up with our function. So the goal is to come up with the two set of these equation, okay, in standard form. So as you recall, you have kind of like ax plus by equals c. You're going to come up with these two, except x and y is your a and b this time. So you see this constant times a, constant times b, constant, like ax plus by equals c. Two equation, two unknown, so that's why you have other second equation. Constant times a, constant times b equals c. There you go. And then you have two equation, two unknown, so you can solve xy. Furthermore, you can use this formula to figure out what a and b is. Okay, so don't get too caught up with the theorem and the messy formula. It's not going to be too bad. And I'm going to show you how to find those equations to approximate. So here's the first example that I want to go over. Okay. The first example says, find the least square line. Least square line is this one right over here. We call this least square line. Y equals ax plus b. So I need to come up with the y equals ax plus b. And then estimate that equation when x equals 7. Okay. Now, since I have to find out, take a look at this notation in mathematics. This is a summation notation. So n represents set of points. In this example, we have 1, 2, 3, 4, 5. 5 points given. So n equals 5. Okay. And then you can say the first order pair, this is like your x1, y1, x2, y2, x3, y3, x4, y4, x5, y5. Getting the notations? The first part says I need to square this, okay? And then this one, I have x and y, all those pairs to be multiplying. I need to sum that up. So I'm going to create additional 2 columns because I need eventually to find out what x and y is. So x and y, and then x square column. And then I'm going to also create the total because I need to sum that up, right? So just creating, add another row and column, and then sum that up. I'm gonna erase this one so that it doesn't get confused. Okay. All right, so let's try this one. Eventually, again, I need to square x term, and then I need to multiply x and y. So let's figure that out. So xy 3 times 2 will give me 6. Correct? 3 times 2, that's what x times y is. 3 times 2, 6. And then the next one, I have 5 times 8, 40. 7 times 6, 42. 9 times 7, 63. 11 times 9, 99. X squared, just square this column 1. 3 square will be 9. 5 square will be 25. Only the x square. 7 square is 49. 9 square will be 81. And then 11 square will be 121. And I'm going to total that up because if you look at the formula, I need to find the sum. That's what the summation formula is, right? So let's total that up. So let's total each one. This entire row, if I total this, 3 plus 5 plus 7 plus 9 plus 11. If I add that using calculator, I get 35. Second column, if I total that up, 2 plus 8 plus 6 plus 7 plus 9, I'm going to get 32. Let's total this one up here, right over here. 6 plus 40 plus 42 plus 63 plus 99. On the calculator, I get 250. And the last column, I'm going to sum up. 9 plus 25 plus 49 plus 81, 121, I'm going to get 285. Okay. Let me also color code these. Okay. So let's come up with our 2 equation and solve x and y. Okay. So my normal 2 equation using the formula, and I will copy the formula here. So I need to come up with the 2 formula. And then I'll put it on the, I'll put it on the side. So I have it handy. Oh, well, actually, let me do it this way. Here's my first formula. And then here's my second formula. All from last page. Okay. So the first equation I have, and then second equation, let's plug it in. This first parenthesis means in the chart, that's x square column, and then whole thing being square, and then summing. So that's your green. This one here, 285. That's your coefficient right there, the sum part, the total part, right over here. This one, right, the sum. This here, in the parentheses, that's just x term, the total, so that will be your 35. And then on the right-hand side, you have x and y summing up, so that will be 250, this one right over here. So my first equation looks like 285a plus 335b equals 250. My second equation, this to me is like this one over here, the orange one. So 35a, n times b, n was 5, the number of order pairs, so 5b. Y column is my blue one right over here, so that's 32. So those are my two equations. Okay. Now I need to solve A and B, right? I need to solve A and B and come up with y is equal to ax plus b. And these formula A and B is just right over here, also given. So I'm going to copy. Okay. Oops. And let's just plug it in directly. Again, let's use colors. So I'm talking about the totals, right? So n, I'll just use different color n. N is number of, let me use red. Okay. So n is 5, so that's where the n is. This first set of parentheses, that's x and y, so that will be the orange total, right? And then the second parentheses, x column, so that will be the orange total, right? Orange total. And then the y total will be blue one. And then n again is your 5 again. X squared is my green total column. And then x of k will be my orange total value. So literally you just have to plug it in. So let's plug it in those numbers. Okay, so you have 5 times 250. Remember, these are my total, okay, because it's a sigma. Minus orange total is a 35. Blue total will be 32. On the bottom, 5, because that's number of order pairs. X squared, green total, 285, minus orange, 35. Let's plug it, square, don't forget the square. Okay. Now, plug it in everything into a calculator nicely. I'm getting A as a 0.65. So your A is a 0.65. B is, let's do same thing, color coded. So y sub k, that looks to me is my blue total. And then A, we already got that number. A is, okay, A, we got it as 0.65, so that will go right over here. X sub k will be my orange color, orange total. And then n will be my red one. Right? So my B, the value for B will be 32 minus 0.65 times 35 all the way 5. All over 5. Plug it into a calculator, I get 1.85. So that's your A and B. Your final answer, remember, least square line is y equals ax plus b. So my least square is y equals ax plus b, 0.65x plus 1.85. And so that's the first part. And we use this to approximate 7 approximate y when x equals 7. So let's finish that. So plug it in 7 for x. I'm getting y as a 6.4. So that is your approximated value. So, and if you look at it, going back, you see that at 7, this is the column that I'm interested in. When x equals 7, y was a 6. And my approximated function is very close, 6.4. Of course, your least square line is an approximated function, so it will not give you exactly 6. It will be very similar to the actual value 6.4. Okay? So that is a whole complete procedure using the equation of the least square method. Okay. So it's not too bad when you break it into parts. Those variable with the sigma looks very messy, but it's not bad. So I recommend creating more columns and rows and then kind of like highlight each part and plug it into the right function value. Okay. So related homework problems for this one is 1, 2, 3, 4, 5. And the next one, I have a application problem, and you can use this one to complete number 9, 10, and 11. So let's take a look at number 2. Number 2 says, the U.S. Center for Disease Control and Prevention, CDC, use a measure called Body Mass Index, BMI, to determine whether a person is obese. A BMI between 25 to 29.9 is considered overweight, and BMI of 30.0 or more is considered obese. The following tables show percentage of United States adults 18 years old older who were obese in the years indicated, judging on the basis of BMI. So we have year 2001 all the way up to 2005 with the percentage obese. Now, I'm going to create a column just like these 1, 2, 3, 4, and then total row so that it's easier for me to use a formula. Okay, so let's create a new table. Using 0 for 2011, find the least square line. Use it to predict percent of adults 18 years older that will be obese in 2020. All right, so this is like your x value 0. That's what they're saying. 0 for 2000. And this will be your y value. So let's create some column. So I have a column for x, y, and then x squared. And then I have 1, 2, 3, 4, 5. So again, my ends looks like I have my n value will be 5 again. And then total column. Okay. So my year 2000 will be 0. 2012 will be 1 because going by 1 year. So 2013 will be 2, 3, 4. At the end, 2020, you're not going to put 2020 in this mean you're going to be using, so 2020 will be x equal 9, right? So this, in other words, I want to know y value when x equals 9. Because 2011 is a 0, so 2020 will be 9 years later. Okay, y value, I have 27.4, 27.7, 28.3, 28.9, 28.9. Let's multiply these two. 0 times anything is a 0. 1 times 27.7 is 27.7. 2 times 28.3 will give you 56.6. 3 times 28.9 is 86.7. 4 times 28.9, 115.6. And then x squared, 0 square will be 0, 1 square 1, 2 square 4, 3 square, I'm talking about this one, squaring 9, and then 14 square 16. So let's total that up, because remember the formula requires totals, sum, right? Okay, so let me see. I'll just use same colors. Okay, so we are being consistent. And I will copy the same one. Oops. Right. Okay. So let's take a screenshot. Oops. Okay. Well, it doesn't copy properly. Okay, so I'll just recolor it again. Okay, so N is my pink one. I'll just pick, it will be different colors. So my X total will be yellow. Then Y total will be blue, orange, and then green. Okay, so if I'm adding 0 plus 1 plus 2 plus 3 plus 4 first column, I end up getting 10. Adding the entire blue column by total, I get 141.2. Adding all these orange column, I get 286.6. Adding entire green column, I get 30. Okay. Now let's come up with our normal equation. The problem may ask you to come up with the normal equation. Then that's how you come up with those two equations. Okay, and then the normal equation. Right there. So these are my two normal equation, the first one and second one. So x squared column this time will be my green. X column is yellow. XY will be orange. X column will be yellow. And then N will be my red. Okay, this tiny one right over here. And then Y column will be blue. Okay, so now you just have to plug it in. So my first number will be 30A plus 10B equal 286.6. So that's my first equation. My second equation is 10A plus 5B equal to 141.2. Those are my two equations. Now let's solve A and B, come up with our least square line, and then use it to predict the value. Okay, so again, I'm going to be using the formula. will copy this one. Copy. Okay, remember, this is my A and this is my B. And then N was 5 order pairs. And I used pink. Okay, so let's do this one. N right over here, right over here, right over here. Sum of x, y, that is an orange column. The next summation will be the yellow total, right? Y total will be blue. X squared will be the green term. And then X summation and then square outside. Don't forget to square the value. B value will be Y column total, so blue one. And then X, which will be yellow. Okay. And then I used A as a purple one for this coefficient right over here. So let's begin with A first. Plug it in. 5 times, I have 286.6 minus 10 times 141.2 all over N is 5, 30 minus 10 square. Plug it in, reducing and then simplifying into a calculator. Final answer A, I get 0.42. B, blue term, 141.2, subtract A, 0.42 times yellow, 10 all over 5. Plug it into a calculator, I'm getting B value as 27.4. So A is, so my equation, so that's the last part, right? The equation, the least square line is y equals ax 0.42x plus b 27.4. So that's the first part. And we need to approximate, remember, the y value when x equal 9 in 2011, right? Continues from 2011 to 2020, what will happen? So x will be 9 this time. So y will be percentage of obese will be, I'm getting 31.18%. Wow, so therefore, approximately 31% of adult population will be considered obese in the year 2020. All right, so that's the entire 2 example using the least square method. Okay, I'll see you in the next video.